Non-parametric tests. When a population is heavily skewed or has heavy tails, the median is a better estimate of center tendency than is the mean. So far we've been using the mean in our equations. Our hypothesis was about the means. So these kind of tests were the parametric tests, and now we are looking for the what we call the non-parametric test, where median can be used to estimate the central tendency. We've been working with the parametric tests so far, like z-test, t-test, and ANOVAs, which have the assumption of normality, that the data is normal for the underlying populations. And in practice, absolute normality is rare. So skewed and heavy tail distributions, they exist in nature. Median is the middle number in a sorted ascending or descending, both of them, list of numbers. So it's a middle number in a sorted ascending or descending list of numbers. List of numbers that can be represented, the size of this list can be represented by n, or sample size. If the sample size is an odd number, if n is an odd number, then m hat, that represents the population median, estimate of the population median. We can get it through the estimate of the sample median, so that's represented by y over this symbol tilde or tilde, people call it. So, and that we can get it through the number that's present in the middle. This m represents the location of that number, and if the list is odd, m we can get it by n plus 1 by 2. For example, we can demonstrate it here. So here n is equal to 5. So we have 5 numbers here, and m we can get it as 5 plus 1 by 2. So m is equal to n plus 1, that's 5 here, plus 1 divided by 2, that's 6 by 2. So it's the third number. So the number which we can get it as a median here from this odd list of numbers, where the numbers are odd, 5 of them, and it's this number. So this n represents the sample size, whereas the m represents the position of that individual number. For n, if it's an even number, m hat estimated by y tilde, that we can get it as y at position m plus the next to m, which is m plus 1 divided by 2. Actually these are the middle two numbers. We can get m as n by 2. So for example, here we have the list of even numbers, and we have 6 numbers here. So n by 2 or m, which we can get it as n by 2, so that's 6 by 2. So it is this number over here, the third number. This is first, second, third, fourth, fifth, and sixth, and then m plus 1. So that means third and fourth, both of these numbers, and we take their average, sum them up, divided by 2. So that's the average of these two numbers. So that is, in this case, we can get it as 5 plus 7, that's equal to 12 divided by 2. So the median for this even number of lists is 6. These two numbers can be treated as, or taken as, this number is the maximum of the lower half, so we can split the data into two equal halves because the list is even. So this is the last number or maximum number in the lower half, and this is the first or the minimum of the upper half, so average of these two. So that will give us the median for a list with even numbers. Test for the median, we can use the confidence interval approach, CI approach, and an approximate 100 into 1 minus alpha percent. This is the generic form of it. So whatever your alpha is, confidence interval can be constructed as 1 minus alpha into 100, so that will give you the percentage of that confidence interval. So if your alpha is 5%, your confidence interval is 95%. If we want to plug in into this formula, alpha is equal to 0.05, so we can get a 95% confidence interval if we set alpha as 0.05. If we set the alpha as 0.1, in that case our confidence interval will be 90%. For a confidence interval of 99%, we need to set the alpha as 0.01. So we use this confidence interval approach to reject the null hypothesis. Remember, we did it before in the t-test, and if our mean under the null, the mean under the null hypothesis, if that is included in those confidence intervals, we fail to reject the null hypothesis. So here we get the confidence interval for the medians like ML and MU represents the lower and the upper confidence intervals, and these confidence intervals we can get through, or we can estimate with the actual data. So we pick up the numbers, and those numbers are y at L alpha by 2. Since it is confidence interval is a two-sided thing, so we go with the alpha by 2. So we can determine these two numbers using a table. So that table has it's a table 4 in our book. So that's where we have the percentiles from a binomial distribution with a p-value of 0.5, and those percentiles are represented by C. So this C represents the percentile, the actually the number to pick, or the location of the number to pick in order to make two confidence intervals. So the lower, which we can get it as L at alpha by 2 is equal to C. This represents alpha two-sided, that's there in the table, and we will look into the row where its alpha is for two-sided test, and since confidence interval is two-sided, and n is the sample size, and plus 1, so we add 1 into it, so this then gives us the location to of the number to pick, and that number will be our the lower confidence interval. And same way for upper, it's n minus c and this whole thing, so n minus c at alpha two-sided for respective number of elements in the list or the sample size. So the CI can be a bit larger than specific, so we can also do it by binomial formula like this. Do it in a moment in an example, then it will be more clear to you.